Hello and welcome to the New Edge with Pensando Systems. Today's event is brought to you by Hewlett Packard Enterprise with Pensando. This event is produced by Actual Tech Media. My name is David Davis of Actual Tech Media, and I'm excited to be your moderator for today's event. On this event, we want you to get all your questions answered, and we encourage you to use the questions box in your audience console throughout the event. I'll call your attention to the questions box right there. And if you click on the questions tab, we'll be answering questions throughout the event electronically as best we can, but we'll be queuing up the best questions for the dedicated Q&A session at the end of the event. We also have today's handouts, the slide deck from the full presentation today that you can download in PDF format in the handouts tab and check that out at your leisure after the webinar. And then finally, we'll be awarding an Amazon $300 gift card to one lucky attendee on today's live event. If you're watching this on demand, I'm sorry, the drawing has already occurred. Price terms and conditions can be found at actualtechmedia.com. And with that, I'm excited to introduce today's expert presenters. They are Mr. Eddie Boujadi, Director of Solutions Architecture at Hewlett Packard Enterprise, and Mr. Kevin Chabot, Worldwide Strategy and Execution for Hewlett Packard Enterprise. Eddie and Kevin, thank you so much for being on the event today.
Thank you, David.
All right, and with that, I'll hand it over to Kevin to kick off today's presentation. Take it away, Kevin.
Hey, good afternoon, everybody. My name is Kevin Chabot. Very glad to be with you today and appreciate your time. As you may know, in October 2019, HPE led a C round of funding along with Lightspeed Ventures and JC2 Ventures to raise $145 million for a Silicon Valley startup called Pensando Systems. Now, Pensando had been around for a number of years, but had been operating in stealth mode and felt like the time was right to come to market. The joint announcement between John Chambers and Antonio Neri, HPE CEO, was really exciting because it brought together two foes, previous foes, coming together to collaborate to bring to market what is going to be a groundbreaking technology. Technology was developed by the people you see on this screen. In the industry, they're referred to as MPLS, Mario, Prem, Luca, and Sony, the first initials of their first names. This group of engineers have been together about 25 years. And when they worked for Cisco, collectively, they invented technologies such as Catalyst, Nexus, UCS, MDS, and ACI. Much of the technology and intellectual property that Cisco still sells today. This is their $9th billion market launch. And I think I can say safely that this is the #1 innovation team in the world. We're very pleased to be working with them. Now, not only did HPE lead the round of funding, but we also invested $50 million and have a seat on the Pensando's board of directors. Now, $50 million doesn't sound like a lot to a company of our size, but typically in a company we don't buy and we're just partnering with and curating, we invest $3 to $5 million. So $50 million is a significant investment for a company that we're not buying. Because I believe our leaders saw an opportunity, a generational shift in the market around security, around networks, and around the edge. Now, when I talk about the edge, we think about the perimeter of a data center or a box that's in a utility box substation. We know that 75 and 80% of the data resides at the edge today. But what edge? There's multiple edges, and I believe the edge is being redefined. We also saw the opportunity to deliver hyperscale technology, much like the cloud providers use, the big cloud providers, to our customers on-premise and do it much more securely. And this technology and solution dovetails very nicely with HP's edge to cloud, everything as a service strategy. Pensando addresses a lot of concerns for our customers. Aging network topologies, bolt-on overlay networks, application performance and latency, and frankly, a sprawl of so many single-purpose appliances, whether it's a firewall, whether it's a tap. And by delivering services in a distributed fashion, advanced networking, always-on telemetry, and deep observability, firewall, and other security features. By delivering those at the exhaust of the server, you have tremendous advantage. One is cost, and one is the ability to scale those services as you scale your compute. They scale together. It's not the way it happens today. You scale out your compute platform, your network still stays the same unless you make significant investments. Think about scaling out your network, security, and load balancing as you scale your platform. We believe the result will be improved application performance, simplified networking for our customers, better telemetry and observability, which is faster resolution time with network problems, and absolutely an improved security posture. As you can tell, I'm very excited about technology. We're very happy to be working with Pensando, and I'm going to turn it over to my partner, Eddie, to take you through the technology. Eddie?
Great, thank you. So let's go back in time just to talk a little bit about the evolution of the distributed intelligence. So we're going to look at the telephony. If you go back far enough to the early 1900s, you see that the edge device was completely dumb. It didn't even have a dial pad or a rotary in order for you to dial a number. It took 60 years for us to come out with an all-electronic switch. The intelligence prior to that was mostly in that person that is running the switchboard. It's all in their head. The intelligence was actually the human being. As we evolved and we started looking at an all-electronic switchboard, if you look at that phone on the side, it was still a pretty dumb edge device. So the intelligence still had not been distributed out to the edge. It was still centralized. It took another 40 years or so, let's say 1990s to 2000s, for the microprocessor, the chipset, the local area networks, the ability for us to have some sort of mobility with, early cellular networks and then eventually 4G, 5G, before we can distribute that intelligence. Obviously, that distributed intelligence makes all the difference in productivity, convenience, flexibility, and everything we do. But it is important to show that we are moving in that direction. And as we evolve, more intelligence moved out to the edge and it becomes distributed. So there's going to be some at the core in the central location and some at the edge. Very similarly, in the compute area, didn't start until the 1950s with the mainframe. But again, you see the dumb edge, which has a monocolor 3270 terminal if you use IBM, but any equivalent computer device was exactly the same way. All the intelligence was in a central location with a distributed dumb edge devices. Fast forward 40 years is when we started looking at the client server architecture, and with the introduction of DOS and the personal computer, the LAN, the internet, and the convergence, then we started to see a little bit more intelligence going to the edge. And of course, here more recently, with all of the innovations that we've seen in smart homes, smart cities, IoT, mobility, and all of the integration that we can do now in a very compact handheld device is really what's changed this industry. And so we continue to see that evolution. More intelligence is going to the edge in order to make us more efficient and more mobile. On the security front, security and telemetry, it is following the same evolution, but it didn't start until the 90s, simply because we didn't have local area networks. And when we introduced the LANs and we introduced client server, that's really when we connected to the internet and we started looking at securing the internet, securing at the time it was called computer rooms. We didn't have data centers, but it was the computer rooms, and we were securing that from the internet. It was very basic, very simple. Firewall didn't have a whole lot of UTM functionality or anything like that. So unified threat management came later as we became more sophisticated with these firewalls. And when I say firewalls, it also should include any type of point products, appliances, and just software agents that would run anywhere you put them on a server. But this is the challenge with security is towards the 2010s, about a decade ago, we didn't have the distributed intelligence in hardware. Most of it was point products. It would run on a server. It would use up CPU resources, memory resources, and you paid quite a bit of money for that server and its resources only to use it for networking and security functions. So until today, we are now using actual hardware to offload all of that security, whether it's centralized, like a checkpoint, like a Palo Alto firewall, or it could be a Guardicore, Illumio, and we're doing microsegmentation on a server. So we're taking all of that and we're offloading that to that PCIe card in a distributed fashion. Why does that matter? It matters because there is an enormous number of devices being connected to the internet. Precisely, IDC says 31 billion by 2021. And as you grow that data and the number of applications, we need to move security closer to the edge. We need to move security closer to the applications. And we want to get to a point where we can secure, isolate, and protect the smallest entity possible. This is what we call microsegmentation, the ability for you to protect a single virtual machine or a single container and isolate it from everything else. Then you move over to the middle section here, and you have the perimeter firewalls are no longer adequate. We used to think that as long as I'm protecting my data center from the internet, then I'm safe, I'm totally okay. That is no longer adequate for two reasons. One is if you have multi-tenancy inside that data center, you want these tenants to be protected from each other, isolated from each other. The other reason is if that perimeter firewall is penetrated, a hacker can roam within the data center freely for 6 months before they're detected. So it could be a major problem, damage to the brand, damage to all your data, and so on. And with all of this, with all of the complexity that we're basically, these appliances and point products do not scale. And so you're going to have to add many of them. So you're going to have multiple devices, multiple appliances and point products and software agents in order to operate. And it becomes very complex to the point that 75% is being spent on operating instead of innovating. And if you look at the very top of that slide, the overarching challenge of all of these things as a backdrop, the biggest problem is most of this data stays inside the data center. And now you're trying to build a secure, segmented, hyperscale, and high-speed network inside the data center. And these are two diametrically opposed points that are next to impossible to do. The ability for you to have a high speed and secure at the same time is very difficult. And so this is what Pensando solves for us. So we want to transform and transition from what is on the left side to the right side of the slide. So we're looking at discrete appliances, point products, software agents, and all of that on the far left that are inefficient. If you look at what you can do in a data center, space, power, cooling. So all of these half-rack size appliances and firewalls need to be decommissioned, isolated, or consolidated somehow because they take up space and they take up a lot of power, generate heat. And they become very expensive to operate. Not only the annual licenses, not only just all the space they take and all the maintenance, but it is the disparate GUI interfaces and the having to train your staff and so on and so forth in order to operate all of that. And even then, with all of the other issues, they still do not provide you the granular security that you need. Basically, a firewall that sits in the middle of the data center trying to do segmentation or micro-segmentation has no visibility outside of the segments it's connected to. So you have to force traffic to it as the gateway in order to make it route and secure between segments. we need to move away from that and move all the way to the right side to show integrated intelligence, where everything has to go through a specific device. In this case, it would be the Pensando PCIe card. Everything is forced through that card in and out, and nothing gets by it without the policy managing that and governing what gets through. And because it is identical on every server, the policy that we push out to it is identical. So there is literally a single policy that you manage, a list of permits and denies, and that is the only thing that you manage. You push it down to all the DSCs, and now you're managing a single device throughout the infrastructure. So we get to a point where we want to either eliminate or consolidate everything on the left side and move it over to the right side in the Pensando hardware. This is where we get the telemetry, we get the firewall, the microsegmentation, the compression, the encryption, many, many services that are service chained. You can turn them on as you wish, turn them off. It's just up to you what you want to enable and what you want to use. Some of these features are here today, and some will be coming in the future in order to continue to grow that set of features and give you a complete feature set. The more features you have, the more appliances and point products on the left side you can eliminate. The other thing is we want to start looking at, instead of stopping at the top of rack switch, if you have an intelligent switch and all you do is ACLs, that top of rack switch is good, has served its purpose. The technology evolves. And so you want to go a little bit deeper. First, it's no longer enough to do ACLs. You want to do stateful firewall. Second, you want to be able to reach the application, reach the virtual machine or the container that is on the server. And the only way to do that today from the switch and out is to install a software agent on that server. We want to eliminate that software agent. Again, we don't want to be using CPU and memory resources on the server in order for us to be doing networking and security functions. We want to move away from that completely. So the new architecture allows you to gain control of all of these things all at once, and yet the ability to save money. In some cases, we've seen some customers that looked at saving about $3,000 per server. It can be enormous. If you have a data center that's doing a few thousand servers, that's a lot of money. So let's look at the architecture itself. If you start in almost the bottom middle of that screen, then you see a normal network, layer 2, layer 3 data center fabric. It is completely independent of what network switch, what network device, as long as it can give us a 1 gig, 10 gig, or a 25 gig connection. And of course, if you upgrade the card, you can go 40 gig, 50 gig, or 100 gig. It is completely agnostic to the network vendor or the network brand. Then you connect all of these servers. You see server 1, 2, 3, and 4 all around that ellipse. Those servers connect to the network with the DSC. It's a network interface card with advanced features, advanced software that goes on it. The difference between that green ring that you see, that light green ring, that becomes that additional layer of protection that nothing goes in and out of a server unless it goes through that distributed firewall that is running on the different DSCs on the network. Compare that with the firewall on the right side that says east-west firewall. That firewall is basically an appliance in a centralized location in the data center, and every server has to push traffic to it and back. It creates a congestion point, a choke point, and it becomes what we call a trombone effect. Everything goes in and out of that firewall on the side. It becomes a very serious choke point and an issue. And this is when customers decide, okay, well, I have a pair of firewalls, and now I need to expand because one of them is just running out of gas. Then you go buy another pair, and another pair, and another pair. And this is where the complexity comes in. So we need to start eliminating these firewalls and go to a more of a distributed model that scales out with you as you add more compute. Another point I want to point out here is the east-west firewall. You see there are two of them. The first firewall is active. The one behind it is in standby mode. You normally don't want to turn both of these active because if one fails, you lose half the capacity. So what you end up doing is you have one active and you're wasting 50% of your investment on the other one that is sitting in standby mode. Okay, so it's an immediate loss or waste of money. All right, so going back to the distributed services platform, if you look at the top of the screen and you see that policy control orchestration, this is what we call the PSM, Policy and Services Manager. That is where the policy lives. The entire data center policy that would be on one or more of your firewalls now transfers to that policy manager, and that is pushed out to all of the DSCs that are distributed throughout the servers in your environment. That policy can be entered from the left side using a GUI. You can say, I want this IP address to permit and talk to this other IP address or MAC address or host to host, but it is entered manually. Or you can do orchestration, automation with the APIs, Kubernetes, OpenShift, VMware, and many other tools, OSs, and third party that would allow us to just combine and control everything that goes in and out of that environment. One other thing that I want to also point out is the perimeter firewall with UTM. We are not replacing that firewall. That firewall continues to be there as a perimeter firewall as an additional layer of protection. So now you have two parts of that protection. You have the UTM, Unified Threat Management, for antivirus, anti-spam, any type of web filtering. So that continues to be there to protect you from the internet. But inside your data center, you need every small component to be controlled and isolated, protected by itself. So let's take a closer look at a few use cases, what it would look like to implement a stateful firewall in this case. You see the data center network in the middle. We said it's agnostic, can be any vendor, any switch, as long as it's standard Ethernet, 1 gig, 10 gig, 25 gig. And you have the S1, S2, S3 on the left side. These are source servers. You have D1, D2, D3 as destination servers on the right side. This can be any combination. We just picked a simple example to show that if you were to go from a source to a source, these could be two completely different organizations, different groups within the same organization, multi-tenancy, could be competitors, could be anything. So we want to block and isolate them from each other. This is where I mentioned earlier, this is the most difficult problem to have because now we want to have them both, S1 and S3, have the ability to go at high speed, communicate with a shared resource on the right side. This is a database, could be credit card transactions, could be patient records, could be anything that is shared that every tenant or every group wants access to. But we want to eliminate the different groups from talking to each other. So traditionally, the way we've done this is use a firewall. This is the firewall that is east-west traffic firewall, and everything goes in that firewall and out of that firewall. And this is where you get that macro segmentation. It is not micro segmentation enough. So it is at a macro level, and it becomes a congestion point. As you run out of performance capacity on that firewall, then you go add another pair and another pair, and it becomes a very complex proposition and very expensive. The next step is to go to a distributed model. This is the distributed intelligence that we want to completely replace the centralized appliances with and give you a factory integrated. You order a HPE server, it comes with a DSC installed from factory, and you basically just plug it in. You find its way to the controller that's in the middle on the bottom. And now that controller identifies that DSC as a safe partner that says, yes, I trust this device. It's a trusted device. And now I can include it in my updates. So you push the policy down, and again, including the entire lifecycle management for any type of patches, upgrades, configuration changes, and so on. But for the security purpose of the policy, you push that same exact policy to every one of these DSCs. So now you have a virtual machine running on D1. It migrates to D2. From the D1 and D2 perspective, that virtual machine sees exactly the same policy because it is identical on both cards. So there's no difference between being on one server or another. Okay, it becomes very, very simple to manage. You only manage one policy, not every card independently, but it's simple, single policy. Okay, so as we transition away from these appliances, then it becomes a direct path between S1 and D1. You can see that green line. It no longer needs to go to the firewall. It goes directly between hosts, between servers. S1 to D1 is now high performance, no choke points. At the same time, we continue to secure S1 to S3. If you see that blocked or deny, that is how we control from S1's perspective or S3's perspective. They're denying that traffic between S1 and S3, but S1 and D1 are okay to communicate. With that, we also eliminate the fault domain. So previously, when you were going through this centralized firewall, you had about 200 to 300 servers dependent on that gateway, on the firewall itself as their gateway. If that gateway fails, let's say you have a software issue and both primary and backup both have that same issue and they fail. You've just isolated, eliminated 200, 300 servers from your environment. With the DSC, the worst that can happen is you just lose one card. Let's say you have a hardware failure, you just lose that one card and you just lose a server. And if you have a high availability server and you really want it to be on all the time, you would just put 2 DSCs in it and that would give you that primary active on both cards. So they're now both active at the same time. You're not wasting any money because you double your bandwidth and you're giving them both active connectivity. And as you continue to deploy more servers, they come with their own built-in integrated CPU, memory, and that processing power in order to continue to scale this operation out. You're no longer having to worry about, am I running out of firewall capacity or encryption or any of these services. It's all now integrated in that DSC. All right, a different use case here is micro-segmentation. So if you look at the big squares, those are hosts or servers. And at the bottom of each of those is the DSC. That is the network interface card that is installed in a server. And you can see the stack, distributed vSwitch. Above that is a virtual NIC for each VM or container. And then at the very top is the smallest component where you would run an application. What you want to do here is the ability for you to govern and control VM to VM traffic. This is as good as it gets. You're doing microsegmentation in hardware and you're protecting every application, isolating it from everything else in that environment on that server. At the same time, you have the ability and the option to encrypt that traffic all the way out to another server in the environment. We talked about multi-tenancy, different groups in the same data center, or it can be a branch office somewhere. But even inside the data center, if you have the option to do encryption and hardware, it does not tax your server, it does not tax the card, the network interface card or the DSC. Why would you run anything in the clear? So that gives us the ability to encrypt end-to-end, any server to any server, regardless of how much security you think you need. It just completely eliminates somebody from tapping the network or looking at anything inside your network that they shouldn't. The third use case is observability or telemetry. And every network administrator would love to have a dashboard that would show them what's going on in their environment. It's the mean time to repair. It's the ability for them to understand capacity planning and doing things, fixing things proactively before they become a serious issue. And usually the network administrator is the first to blame when there is any type of slowdown on the application, any type of congestion. It's usually, oh, network problems. You know, they go to the network guy and just ask them to look into it and fix things. So the network guy needs to be able to say, nope, it's not me, or yes, it is me, and I know how to fix it. So they need these tabs to be distributed throughout the environment, throughout the data center. The only problem is they are very expensive. You cannot afford to put one on every server uplink. They're about $1,000 a piece for a 10 gigabit tap. And you cannot put them in the core because they don't have that visibility and they're not granular enough. So you have this balancing act between spending money and having visibility. And so they are considered optional devices until they're required. The issue with that is just when you need a tap to be where the problem is, you don't have one. Just like on S1, I intentionally didn't put one to give that example to say, if S1 has an issue, then what do you do here? You don't have any visibility, except maybe from the switch a little bit. You might do net flow, but I'm talking about a tap that can actually give you packet captures, net flow, and everything that you want to see to isolate a problem. So we distribute these DSCs that have an integrated tap always on. The always on allows you to see this, again, green flow between S1 and D1 and would report that to a collector. Always on can be where you're always collecting net flow information, but just when you need to do a packet capture, you have the option to turn that on for a specific IP address, a specific flow, a specific session. You're not going to bog down the rest of the link because you're just turning everything back to the collector. You can be very specific and filter on what you want to collect. But the point here is you can now see both ends of a link because it's distributed, it's everywhere, and you have the option to collect that data. So if you send me a specific packet at, 200 microseconds and I receive it 202 microseconds, and it took so long to go through the network, that's wonderful. It's very fast. If it takes 2 milliseconds, then I know I have congestion. I know somewhere in the network it's taking too long, and I need to look at that and see where I can fix it. Same thing with drop packets. Same thing with DDoS attacks, spoofing, IP spoofing, MAC spoofing. There are so many things that you can start isolating simply by looking at these taps or dashboard and do this proactively before they happen. But we want to get to a point where we can eliminate all of these additional taps. It's another layer of devices to manage. It's expensive, and we need to just remove them from there. Okay, so these are the 3 use cases, but we can go on. And as we continue to develop more features, they will be added to that DSC. You just basically download and enable. It just becomes a very simple process. So this is kind of what we've talked about. There are many, many advantages to moving to this modern architecture, to change from appliances, devices, point products, software agents, and so on, into this distributed hardware platform. Many advantages, but I had to pick a few just so you guys will remember what we're talking about. And the few would be, my top priority would be granular security, the ability for you to do a firewall, microsegmentation, and end-to-end encryption on every server all in one place. The second one would be improved uptime. No longer do you have to depend on a gateway to be up or worry about a firewall to get you from segment 1 to segment 2. It's all direct paths, any to any. High performance, of course, is very important. You completely eliminate the choke points. You offload the server, CPU, and memory, and you make that everything runs in hardware on every device, on every server. Nothing goes in and out of that network without you controlling and governing what happens on that network. And of course, we will save you money. Let me put it this way. If we don't save you money, that means you really have not been spending money on security. That means you might be exposed a little bit. If we show that our TCO tools will save you money, that means you've done a lot of good work on security, but you didn't have all the necessary tools, appliances, devices to make it happen in a distributed fashion. And this is where we'll show you that we're going to save you some money. And HPE and Pensando took this all the way. So we're not going to just go drop a box off at your doorstep and leave. We're actually going to help you with that transformation journey. We expect this to take many months. In fact, it could take a few years for you to transform, depending on the size of the data center. So on the far left, you see a tech trial. You see at the top 3 servers and 3 DSCs. This would be at no cost to you. We'll be happy to do a POC, proof of concept, a starter kit. We come out, we do whiteboarding sessions, we educate you on the architecture, we show you a few examples, whatever needs to happen, and we'll let you run for 60 to 90 days in your own environment. If you like it, then we ask that you have some stake in the game. You go into a pilot phase. A pilot phase means you have to purchase a few of these DSCs and maybe some servers as well, and run that in a pilot environment. So it's somewhat production. You run production applications on it, workloads, and make sure that it is doing exactly what you want it to do. And you have the option to move on to the third phase, which is complete transformation. In the third phase, this becomes a complete consulting, education, planning, and deployment from our professional services team, what we call ANPS, Advisory and Professional Services. They'll take you throughout that whole journey down to the deployment and everything that you need us to do. We can do it with partners. We can do it with you. We can do it all 3 together, HPE partners, and you as a customer. And if we do this as a service, the ability for you to pay as you go, what we call GreenLink. If you do this in a as a service model, you have the option to pay monthly for any new additional DSCs as they are deployed, as they go in. And in that case, you might be, any money that you're saving from decommissioning the big appliances, you might be able to self-fund this transformation and this new project. It is complete innovation to the point where as we move forward, we're going to start integrating with additional HPE products, software. You're going to see quite a few things coming down the line, from storage to branch office to analytics and insights, many other things coming down the pipe.
Guys, Eddie did a really good job of talking about the unique elements of our relationship. I mean, you know, the $50 million investment, the partnership with Chambers and the MPLS team. Just to put some things in perspective, we have a number of programs where we invest in and curate companies. Our primary program is called Pathfinders. It's not uncommon for us to invest $3 to $5 million in those companies. We curate them, we give them access to best practices to our sales teams. But a $50 million investment in a company that we didn't actually buy is very significant for us. So, and we are the only OEM to make that kind of an investment. And further, we're going to provide tremendous differentiation around this partnership. We'll be the first to deploy and certify this platform across our entire portfolio. An award-winning, world-leading industry standard portfolio. I mean, we've got the best servers in the world. The other thing I'll tell you is security. If you don't think about this card for anything else or this technology, anything else but security, that's a key point. Today, HP makes the most secure servers in the world. I'm not saying that pounding my chest, it's just true. Our Silicon Root of Trust is unrivaled, patented, and the only one that's received more cyber certification awards than any other server in the market. What's unique about Pensando, the PCI card also has a Silicon Root of Trust on it. Which creates a bit of an air gap between the card and the server. It really reduces your fault domain. So the most secure server in the world just got more secure. We have built and are continuing to build a suite of services. Eddie referred to them a little bit around this product, from education to deployment to consulting, advisory, as we take our customers on this journey, starting with telemetry and deep observability, all the way through firewall, microsegmentation, load balancing, encryption. Only HP can deliver all the services around that and make it real for our customers. And lastly, GreenLake. If you're not familiar with GreenLake, it's an industry-leading consumption as a service model that we deployed about 3 years ago. It's been very, very successful. And again, I think it's a great opportunity for us to have a position or help our customers transform, not just managing the environment that they decide to buy over a period of 4 years, but transforming that environment. That's what we should be doing as a technology provider, not just selling you what you want to buy. We should be helping you transform in best practices. So this technology enables us to take a customer on a journey, starting with telemetry and observability. As we start to deploy additional services, the opportunity to just take out single-purpose appliances, reduce their fault domains, maybe eliminate some overlay technologies that are putting a drag on your server resources. But GreenLake is a great opportunity for us to do all that and deliver it as a service. And that really dovetails into HP's edge to cloud, everything as a service strategy. So listen, if I can press one thing on you, HP and Pensando together are a very different type of relationship. It will not be an exclusive one. But we today have first mover advantage, and we're going to keep that first mover advantage throughout the life of this relationship. So, Eddie, with that, I think we may have concluded, right?
Yes, we can open it up for questions if you have any questions. David, do you want to lead us through the questions?
Yes, sir. Absolutely. Yeah. Great presentation. Really, really cutting edge, innovative stuff you're talking about here today. So thank you for sharing that with the audience. While we do some Q&A, I'm just going to bring up this poll question, and that says, what additional information would you like about the HPE Pensando solution? And I'll leave that up for the audience to answer. So first question that came in, they're asking is, do I have to install a DSC in all my servers for this to work?
I can take that one, Kevin. So
sure,
the answer is no. We don't expect customers to do a complete refresh if they have a large data center, hundreds or thousands of servers. We don't expect that to happen overnight. And so every time you add a DSC to a server, you can start seeing the benefit for that server. And you start migrating that server away from the centralized firewall, and it becomes its own independent firewall, telemetry, microsegmentation, encryption device, and no longer dependent on the firewall. So no, you can start seeing benefits immediately as you move away from old to new.
Nice. I like that. All right. Next question. Let's see. They're asking, do you have to install any software on the servers? And if so, how is that managed or controlled?
Yeah, Eddie,
question.
Yeah,
Go ahead,
sure, I can take that. Yeah, there is a software license. The software is actually on the card, and so you get kind of an electronic license to deploy. And there'll be fundamentally two options. There'll be kind of a silver option, which will give you telemetry, deep observability, and visibility. And then there'll be a platinum license, which will enable you to deploy all of the features as they roll out over time. So at initial launch, stateful firewall, microsegmentation, telemetry, and observability will all be features. That platinum license can be purchased, and then you can deploy those services over time. But yeah, you do have to buy an enabling license for each card, and then there is a policy manager license, which allows you to manage up to 3,000. It covers 3,000 systems, so it covers a pretty big domain. But that's the way it's licensed. So there's a feature enabling license per card, and then a policy manager, which can manage up to 3,000 systems today.
Okay, so let me add to that, Kevin, real quick.
Yep.
So Kevin answered that from a licensing perspective, more of a business level perspective. But from a technical perspective, there is absolutely no agent, no software that is installed on the server. The only thing we require is you install a driver, just like you install any network interface card driver to recognize the NIC in the server. The DSC requires a driver, but no agent on the CPU, on the memory to run. It's all in the DSC hardware itself.
Yeah, good clarification, Eddie. Yep, good point.
Nice, nice. So let's see, there's a couple follow-up questions here about servers. Like, is this, can I add this to existing servers, and does this work on all HPE servers?
Eddie, you want to take the all HPE servers one? Yeah.
Sure. So it works today on most HPE servers, Gen 10 or newer. So as we come out with Gen 10 Plus here in a couple of months, it will work on the Gen 10, Gen 10 Plus. And the platforms that it works on today is most DL servers. So DL 360, 380, 325, 385, 560, 580. So almost all DL servers. The Edgeline 8000 available now, and Edgeline 4000, 1000 will be available later this summer. And Apollo will be mostly available by summer timeframe as well. Synergy, if you're a Synergy customer, that will be coming next year as a mezzanine card that will be added to every compute node. So basically, we've covered almost everything that HPE makes. Just like any NIC card, any network interface card that you buy from anybody to use the network, this would be supported moving forward, would be just a standard NIC.
Yeah, that sort of answers to the, can I go back in my existing environment? So Gen 10 forward. The other reason we're primarily targeting greenfield opportunities is that's really an opportunity too to potentially address replacing some network devices. And lastly, as you guys know, your technical audience on the phone, generally when you deploy a server and turn it on, you just really don't like to ever turn it off again. So we're really looking for go-forward opportunities, if that makes sense.
Excellent, excellent. All right, let's see, another question that came in. Brian, he's asking, is this a product for a smaller school environment? I'm curious about also kind of the general use case. I mean, what are the most popular use cases or, types of companies that are implementing this?
Yeah. So, Brian, I think you're going to see incredible benefits regardless of the size of your environment. So you're going to immediately start to see telemetry, observability. You're going to be able to do microsegmentation, firewall, encryption. Regardless of how small, you're going to use those services and features to give you that dashboard, to give you additional visibility that you don't have today. Larger customers benefit more, however, because they have more segmentation inside the data center. So let's say they have payroll on one virtual machine. They have patient records on another virtual machine. They have student records and so on different virtual machines. So they have more segmentation to do, but you can do the same thing on a smaller scale. So obviously the larger, the more savings you're going to see, but there's absolutely no reason why you can't use it in a smaller data center.
Excellent. I like to hear that. Next question, Will is asking, what's the advantage of moving security closer to the edge and not keeping it centralized?
Yeah, so Will, this is the problem with centralized is too far away from every VM, every container, every host. You want to distribute that intelligence. You want to distribute that security to get it closer as you can to the application. And one way to get it close to the application is to get it closer to the virtual machine or container. So if I can isolate every VM in its own firewall domain, that's what we call microsegmentation, then I've protected every machine, every virtual machine in its own domain, and I don't have to worry about getting attacked from my neighboring VMs or getting viruses, infections, anything like that. Think COVID-19. You want to keep that 6-foot distance between you and the next guy. This will do exactly that. You put that DSC in the server, and you have control now up the stack between VMs, and you have control out the Ethernet port to the network with a stateful firewall. It gives you complete security control. It's that additional layer of security that most people don't have today.
Hey, Eddie, I want to make one more point there. With the advent of so much traffic going east-west these days, inside the data center. Firewalls have had to kind of be repurposed for east-west traffic. In that journey, going from a source to a firewall and then to a destination and back, there are segments of that journey where the data is not encrypted. You're not going to have that with this technology. And I agree with Eddie about keeping things close to the application. You think about telemetry and observability. Those and you think about the pillars of observability, logs, trends, and so forth. Those really only become valuable if they're really close to the application. They understand the application, they see how it behaves, and telemetry really becomes much more powerful the closer it is to the application.
Nice. I like this. Let's see. A next question Erica's asking is, because of all the hardware you mentioned, is this hardware only, or is this software only, or does it require both hardware and software? It might be good to clarify that one.
Okay, sure. So inside the server, I would say it is hardware only. There is software, but the software runs on that hardware, right? So we add the DSC, which is a lot like a network interface card with advanced functionality and features, but no software agent runs on the server itself. That is the biggest difference between this solution and the 10-year-old other options you have on the market, is that we run that distributed firewall, distributed telemetry, distributed encryption. It all runs in the card on the DSC, as opposed to as a software agent. So there is no software agent. And to give you an example, if you had an encryption agent on a server, you have to dedicate an entire CPU core to do just encryption. Literally, you would have to dedicate an entire core to do encryption. We do that encryption on the hardware in the DSC, completely offloading that CPU and giving you that resource back, which you already, you spent money on it, not to do network functions and security functions, but rather to do workloads. And so we would give you that resource back to use for your workloads.
Nice. I like that. And what about the availability of this? Is this something available now, or what's the plan?
Yeah, I can take that. So the product is pre general availability right now. We are selling private SKUs and software releases to select customers. We're spending a lot of time and energy advocating for this and building awareness within our sales team and within our customer community. I think Eddie and I, since November, have done well over 200 customer presentations. Tremendous interest for the product. The product will go GA. We call it GA General Availability on June 1st. At that time, the initial software release with microsegmentation firewall and telemetry and observability will be available, and it will be available to purchase through normal channels, direct and indirect, at HP.
Excellent.
That answers that question. Yeah.
Absolutely. All right. Well, this has been really good. I've learned a lot about this new HPE Pensando solution here and how it can help companies of all sizes. I think that's really cool. Eddie and Kevin, thank you so much for being on the event today.
Thank you, David. Thank you, everyone. Really enjoyed having you.
And thank you to our audience for joining the event today. I hope that you learned a lot. I know that I did. Before you go, I want to remind you to download the handouts in the Handouts tab there. And of course, I want to announce the winner of our Amazon $300 gift card that's going to Robert Oakley from Colorado. Congratulations, Robert Oakley from Colorado. And finally, make sure you visit hpe.com for more information. And thank you to HPE for sponsoring today's event. We'll see you next time. Have a great day.
Thank you, everyone. Bye-bye.